Hello there. Today we'll be doing the problem called two-sum. We'll start by understanding the problem, what we're doing, what we're trying to solve for. We'll match to an array type problem. This is an array type problem. So we'll be matching for sorts, two-pointer, sliding window, and we will be sorting for hash. All right, then we'll come up with a plan, implement the solution and plan, review whether our implementation works correctly, and then we'll evaluate runtime complexity. So what we have here is that we will be given an array of items to look for a target. Target is called a 9, and we're seeing how we can add up these items to get to 9. We need to return the index in any order possible. So if that's the case, then what if there is no answer? Is that possible? So in that case, I think what we should do, well, it looks like there will always be a valid answer exists. So don't worry about that. There will always be something to return, and there will always be at least two numbers in the array. So there are no edge cases that we need to specifically look at and handle at this point. Everything seems to fulfill this particular formula, that all the inputs fulfill this formula. So another thing is that our runtime has to be less than n squared time. N squared. So to do that, generally you use a sort. This would bring the runtime to n log n, which is great. Or we can use a hash. So the runtime is O of n. So I can see a way of doing this with a two-pointer solution after a sort, which would allow us to do a n log n, because after sorting, we can look for a small number and a large number and bring those numbers closer together until we get our target, which is, so we start on the left side and the right side. And we bring the right side closer to the 2 to see if we can find a number that would get to 9. But let's do this on the more optimal way, and let's do this with the hash. So here's the plan. What we're going to do is create a hash table, and then with the hash table, what we'll do is we'll insert the index as the key, well, I think we should insert the index as the value, and the counterpart as the key. Once we find the counterpart, then return the index of that key and the current index. So this happens while we're iterating through each number. So while we're iterating through each number, we'll insert the index as the value and the counterpart as the key. Once we as we iterate, we'll look for the counterpart, and we'll return the index of that key and the current index, because that is equal to the target. Okay, so with that, let's implement the solution and see what we can get. All right, let's implement the solution. So let's call this a counterpart to index as our dictionary. And so we're going to iterate through each number, and we're going to add the counterpart to our check the number for the counterpart. If num in counterpart to index, then we will return, oh, we do need the current index, don't we? So we do need to enumerate nums, and this will get us the index and the number. So index and the number. Let's return the counterpart to index at this particular number, and let's return this current index. And with that, we have our answer. Otherwise, let's keep inserting the counterpart into our nums. So counterpart to index at the target minus the nums would be our counterpart. As you can see, 6 will show you that 9 minus 2 is our counterpart, which is 7. And when we look for 7, when we get 7, then we'll find that index, and we can add the current index and the previous index. So let's set this index to index. Okay, with that, we are complete. Let's review this problem. So let's look at our first item. Because all items are the same, we should be completely fine after we check the first one. So we have counterpart to index, this is our dictionary, and we currently have nothing in the dictionary. Then, as we insert the next, if we check for the number in the counterpart index, and it does not exist, so we'll add the counterpart. So 7 is going to point to the index of 0. So then we find 7 actually in the next item, next iteration, and with that we will return. What we'll return is we'll return this particular index 0, and we'll return this current index, which is 1. So this is the correct answer. So with that, let's evaluate the runtime. The runtime is going to be O of n, and the space is going to be O of n as well, because we do need to store each number. And so with that, let's run it and make sure this works properly. Let's see. So counterpart to index has been spelled incorrectly. That's okay. A little error here. And everything has been accepted. Let's submit. And we are good to go. So with that, if you enjoyed this video, like and subscribe. Want more videos, check the link in the description below. Thank you very much. I'll see you in the next one.